Hello, I am Sankal. Today we are going to learn about embedded system softwares. So before that, let us know what are embedded systems. So as you can see, these are some examples of embedded systems. So embedded systems are specified computer systems designed for specific functions. They are used in various industries such as automotive, healthcare, and consumer electronics. So as you can see, the embedded systems are specialized computer systems designed for specific function. So a gaming console, camera, smartphone, printer, television, all these are embedded systems which are used to perform a specific task. Embedded systems require a combination of hardware and software to operate effectively. An embedded system just can't work on the hardware or the software. It needs to work on both of them effectively. So, embedded system software. Embedded system software. An embedded system needs software to drive it. A figure below shows four typical software components required to control an embedded device. Those are initialization, device drivers, operating system, and application. So, initialization code. The initialization code is the first code executed on the board and is specific to a particular target or group of targets. It sets up minimum parts of the board before handling control over the operating system. The first code executed on the board when the device is powered on. Boot code is present inside the ROM and is responsible for leading the OS to the RAM. The initialization code handles three administrative tasks prior to handling control over to an operating system image. These administrative tasks can be grouped into three phases: initial hardware configuration, diagnostics, and booting. Initial hardware configuration. Initial hardware configuration normally requires modification to satisfy the requirements of the booted image. For example, the memory system normally requires reorganization of memory map as shown in below example. This figure shows memory before and after reorganization. It is common for ARM-based embedded systems to provide memory remapping because it allows the system to start the initialization code from ROM at power up. The initialization code then redefines or remaps the memory to replace RAM address, an important step because then the exception vector table can be RAM and thus can be reprogrammed. We will discuss about this later in vector table. So next, diagnostics. Diagnostics is a program embedded in initialization code. Diagnostic code tests the system by checking if all the hardware components is in working condition. It also tracks down system-related issues. The primary purpose of diagnostic code is fault identification and isolation. Booting involves loading an OS image to RAM and handling control over to that image. Once booted, the system hands over control by modifying the program counter to point into the start of the OS image. Sometimes to reduce the image size, an image is compressed. The image is then decompressed either when it is loaded or when the control is handed over to it. Device drivers. The device drivers are the third component shown in the figure. They provide a consistent software interface to the peripherals on the hardware device. Software libraries that initialize the hardware and manage access to the hardware by higher layers of software. It acts as an interface between the hardware and the operating system, middleware, and application layers. Operating system. The operating system provides an infrastructure to control applications and manage hardware system resources. Many embedded systems do not require a full operating system, but merely a simple task scheduler that is either event or fault driven. An operating system organizes the system resources, the peripherals, memory, and processing time. Operating system can be divided into two main categories: real-time operating system (RTOS), used in embedded devices, and they don't use secondary storage, which are further classified into hard real-time operating system, used in hard real-time applications, which requires the guaranteed response time. Second one, soft real-time operating system, used in soft real-time applications, which does not require guaranteed response time and the performance generated when the time overruns. The second type of operating system is platform operating system (POS), used in general purpose computer systems, and they use secondary storage. Require a memory management unit to manage large non-real-time applications. The Linux operating system is a typical example of platform operating system. Finally, an application performs one of the tasks required for the device. For example, a mobile phone might have a diary application. There may be multiple applications running on the same device, controlled by the operating system. The software components can run from ROM or RAM. ROM code that is fixed on the device. For example, the initialization code is called firmware. The operating system schedules applications which are code dedicated to handling a particular task. An embedded system can have one active application or several applications running simultaneously. ARM processors are found in numerous domains, including networking, automotive, mobile, and consumer devices, mass storage, and imaging devices. For example, the ARM processor is found in networking applications like home gateways, modems for high-speed internet communication, and 802.11 wireless communications. The mobile device domain is the largest application area for ARM processor of mobiles. The ARM processor also found in mass storage devices domains such as hard drives, products such as inkjet printers. So let me share you a fact with you. Uh, all of the processor what you see, Intel or AMD, when it's not Intel or AMD, it's 90% sure it's an ARM processor. These are the examples of some ARM processors. So these are the topics which we learned today. Hopefully you go through them. Thank you for staying with me till here. If you like the video, please like it and share with your friends.